thank you to everyone who's joining us this morning. This is the third in this series, and we're delighted to have you with us today. It's going to be a fascinating discussion. I think you'll all learn something. I have certainly learned quite a lot during the preparation. I'd like to start by thanking the German Embassy for sponsoring this series and for helping us bringing expertise from Europe so we can learn. And we have Wolfgang here today, who is that expertise, who I will introduce later. But I'm going to pass first to Ambassador Sparwasser to welcome us today. Thank you.
Thank you, Diana. Welcome to our webinar, which is the third in our Building Back Better series. Again, a big thank you to Corporate Knights and to Diana for hosting this. As in previous talks, we want to pick up on areas in which both our countries, Canada and Germany, can make a leap into a more sustainable future, become leaders of innovation, and have win-win by working together. That's the case in many areas like artificial intelligence, hydrogen, natural resources, and it's the case when it comes to the subject of lightweighting. It's a declared technology of interest in Germany, and it's a technology which we have a particularly good cooperation between Canada and Germany. In a carbon neutral future, lightweighting will be crucial for mobility, for electric vehicles, or for net zero planes. And I just saw yesterday that Airbus has said they want to have one flying by 2035, a net zero plane. So every kilo less is energy saved. And our industry in Germany, Leichtbau and BASF are represented here, are very, very engaged in finding the best solutions. Carbon fibers are one of the most promising ways to save weight. They're still very expensive, but that has been said also about hydrogen, which is now the solution of choice for filling a lot of our clean energy needs. Canada and Alberta could be prime producers of carbon fibers. So we want to know, is this the win-win solution, a win-win solution for our two countries, for the climate, for building back better? So I'm very interested in our panelists' take. Thank you.
So I will now pass to Toby Heaps, whom you all know, to give us an introduction to this session and what we're really talking about.
Thanks, Diana, and thanks, Ambassador. Some people see things as they are and ask why. Others imagine things as they could be and ask why not. The discussion we're having today is really on that latter piece. We have a slide that we put together with some research from colleagues in Alberta and other folks looking at what is today in terms of the bitumen billions that Canada makes. And this year, it's estimated that we'll make about $27 billion from selling oil and gas for combustion derived from the oil sands from about 3 million barrels per day. What you see on the right is what could be. If we in Canada and in Alberta can figure out how to cut the cost of producing carbon fiber in half, the bar on the right shows the potential size of the prize for our country in terms of annual exports by 2035 in the $44 billion range. That's a large amount of value. It's a high potential yield value as well. And it's something that will only happen if we get a lot more serious about the magnitude of this opportunity, which is starting to gather a lot of momentum thanks to great work by folks, including folks that are here today on the panel, especially John Zhou's work through Alberta Innovates and some of the leading companies like Suncor. It will probably take, according to the estimates of Corporate Knights, in the order of $1 billion of additional investment into R&D over the next 5 years, ideally mostly funded by the public so the IP can remain in the public and doesn't create new barrier to entry, and probably require something in the neighborhood of 10 times that amount to help the crowd in deployment capital quickly following the technology breakthroughs in the years following. So this is a huge potential prize. Right now, we do not make almost any money from carbon fibers, and in as little as the middle of next decade, we could be making as much money from carbon fibers as we are making right now from selling oil and gas to be burned. So it's a huge opportunity for us to look at. And just to put it in perspective, the amount of barrels that we produce currently to make our $27 billion is in the neighborhood of 3 million barrels per day to get that carbon fiber, that $44 billion of carbon fiber market, that would require 75,000 barrels a day. So just 2.5% of the total barrels per day that we are currently selling right now for combustion and making 27 billion from. So big opportunity, much smaller footprint, many scenarios how this can go forward, but we do need to get serious about it. And so I'm really honored to have with us today our esteemed panelists. These folks are not dreamers. They are the doers. They're the people who are doing the hard work to close the gap between what is and what could be. And we're looking forward to a vigorous discussion. So back to you, Diana. Thank you.
Thank you so much, Toby. Well, Toby's painted a pretty appealing picture. It's not an easy thing to achieve, and so we'll see where we get with it. But I'd like to start with Zhou, who is the VP of Clean Resources at Alberta Innovates. And it is Alberta Innovates that's done a lot of the work in the area to demonstrate the opportunities or to and to show what would need to happen to take advantage of them. But John, can I ask you what options you've considered in this space and why you think carbon fibers would be good? But in addition to that, can I just ask you to give the audience a little bit of background on what we're talking about chemically here, what we take from the barrel to make the carbon fibers? Thank you.
Thank you, Corporate Knight, for including me in this panel. It's a real honor. Yes, Alberta Innovates started looking at the carbon fiber opportunities as a part of our Bitumen Beyond Combustion, or BBC program a few years ago. As a leading research and innovation organization in the province, Alberta Innovates has been always looking at the ways to generate more values and reduce environmental impact from our resource development. As Toby mentioned, we are producing 3 million barrels a day bitumen right now, and most of those bitumens are used for transportation fuel. As a transportation fuel, bitumen has low value and emit GHG like other hydrocarbon fuel. But in BBC, in Bitumen Beyond Combustion, we set out to find new ways to use bitumen, not as a transportation fuel, but for value-add non-combustion materials. We want to make materials actually worth more than transportation fuel, but have a lower GHG emission. And will even have positive environmental impact in mass deployment. So, as a first step, we have been focused on the H14. Diane asked about, a bit components in the bitumen. H14 is the heaviest component in the bitumen, and that is gave as a grief of bitumen as used as a transportation fuel. You have to take this thing out. So we are now essentially focused on this component to convert H14 to value-added material. This search lead us to carbon fiber, activated carbon, ash for the binder, and a couple of other products. Among these, carbon fiber seems to have the best potential. It has a lightweight, higher strength, and it's corrosion resistant. And in application, it certainly has lots of benefit. However, as mentioned already, carbon fiber market is very small right now. And certainly there are challenges to get carbon fiber into the mass market. I'm sure other panelists will talk about this, but we believe using H14 as a feedstock can overcome these challenges. So I will get into a bit more detail later.
Thank you so much, John. I'd like to move now to Carrie. So Carrie Fanai is Program Lead of Bitumen Value Chain Optimization at Suncor. Carrie, Suncor has been collaborating with Alberta Innovates and supporting their work for many years. Can you tell us a bit about how this carbon fiber opportunity looks from Suncor's perspective?
Sure, thanks, Diana. And thanks for having me this morning to Corporate Knights, Diana and Ambassador Sparwasser. It's my pleasure to be here with my fellow panelists. Yeah, lucky for me, I have it in my title, optimizing the bitumen value chain. So yeah, Suncor has proudly supported Alberta Innovates Bitumen Beyond Combustion initiative since the beginning in about 2016, being part of both the phase 1 and phase 2 studies that are available online. And now through their strategic advisory committee and of course the Carbon Fiber Grand Challenge. So the idea of carbon fibers from bitumen is targeted at utilizing a portion of the bitumen barrel that we currently work very hard to manage, to separate, to remove, and that contains asphaltenes and is sometimes more commonly referred to as the bottom of the barrel, or that very heavy resid portion. So we do this currently either by coking or by a form of partial upgrading that we call PFT, paraffinic froth treatment. So the objective of BBC is to add value to our bitumen through non-combustion applications, as was described, meaning alternatives to transportation fuels. And of course, Suncor, we're in the transportation fuel business. If carbon fibers can be generated from a portion of the barrel, such as asphaltenes, which is actually a solubility class, we could use that portion to create a value-added product. And so our purpose at Suncor is to provide trusted energy that enhances people's lives while caring for each other and the earth. So as stewards of our precious natural resources, ensuring that the most value is added to those resources by making use of the whole barrel is really an important role for us to play. Suncor produces close to 700,000 barrels a day of bitumen, and the majority is integrated, meaning we upgrade or further refine. So that's a significant feedstock base that we could use for a wider range of products. So other opportunities that John touched on, activated carbon, asphalt from bitumen, metals, these could all be evaluated for their economic potential and also synergistic compatibility to our operations and asset evolution. So addressing the challenge of climate change has pointed to the need to transition to a greener economy. For us at Suncor, that has meant not only focusing on improving the GHG intensity of our existing production, but looking at new products, energy sources, and related lines of business. So it'll take significant work and resources to prove out carbon fibers, both technically and commercially. We call that technology readiness level and commercial readiness level. So those two aspects have to advance in parallel and be customer informed to make sure any work is progressing towards a marketable product. And that's why it's really important to be part of these full value chain conversations like today.
Thank you so much, Carrie. Can I just come back to you on one point? What is happening at present to that asphaltene? Is it just a waste product at present?
Well, at the moment, like I mentioned, we treat it by coking. So in order to get the most value out of that heavy resid bottom of the barrel, Suncor, we do process it as coke. Some refineries, upgraders can also make asphalt, although that's often through a blend of different crudes. So, or like I mentioned, we do treat it and process it through a form of partial upgrading called paraffinic froth treatment. So there's a few ways that we do work towards extracting value from that heavy portion where the asphaltenes reside in that heavy portion.
This would be an entirely different manner of product. Well, we've heard now about the potential, and we can get into some of those technical challenges and challenges around the market. I'd like now to turn to Wolfgang Seeliger, who is CEO of Leichtbau-BW, which is a collaborative network of more than 2,000 companies and 300 research facilities that are working around lightweight materials in Germany. So I think you're further ahead in your thinking about the markets. And I know, as the ambassador said, this has been an area of focus for you, the issue of lightweighting, but carbon fibers in particular. Tell us what the market size that we've been talking about, tell us whether that you think that makes sense from your perspective in Europe, please.
Well, thanks, Diana, for thinking we are ahead of everything. I dispute that. I mean, we've been doing that for the past 6 or 7 years, working in the lightweighting area. So we do have some experience, and I would like to share that with you here. I guess I have got to be the one who spoils the party a little bit, because our thinking goes along the lines that we, first of all, I think we should be trying to discuss why we are doing lightweighting. There's two reasons why we do lightweighting. First is an economic reason. We can make our products more competitive. We can make them. There is a huge market, as you noted before. So it's very attractive to companies to do lightweighting. And the second reason why we are doing that is because it's ecologically good. It's a good thing for the environment because we can save CO2 and we can save other emissions. We can save material resources. The only thing that does not always hold for carbon fiber, especially in Europe now, in Germany, after, well, about 10 to 15 years that we have been doing that lightweighting with carbon fibers. There has been a lot of critical voices about the environmental impact of carbon fiber. And for example, in the car industry, where we are trying to introduce that on a large scale in a mass market, people found there are studies around telling us that making the carbon fiber uses more CO2 than it can save in the car when I use the car. So there are certain areas where carbon fiber does not make sense in lightweighting, and that's one of the reasons why we work a lot with conventional steels or high-strength steels, aluminium, even magnesium. And on that background, with that reasoning, we think that carbon fiber does have a certain area of application. For example, in aerospace, it is very justified there, where an airplane is about 20 hours per day in the air, and you can save a lot of energy running that, operating that aircraft, and that sort of gives a payback in the final balance between emissions and in making the material and using it later on. But this is certainly not the case for a mass market like the car industry, the automotive industry. That is something where the market, and then there's a second thing which we consider critical. If you look at the automotive industry or comparable industries, you need a very, very fast cycle time in manufacturing parts. It's like if you make carbon fiber parts for a car, for example, you're in competition with steel, with steel sheets being pressed with a cycle time of around about 7 to 20, a maximum of 20 seconds. Whereas making a carbon fiber part will take you 1 to 2 to 3 or even more minutes, i.e. the investment for large presses to actually make the carbon fiber components is so huge that it never get a payback on that kind of cycle time, which makes carbon fiber parts rather expensive. And there's a certain limit to which you can reduce the cycle time, we found out here. But Chris, thanks for the slide. We still need that. What we think is going to happen with the carbon fiber, and that's what we are seeing in Europe at the moment, is that in markets with low volume, like the aerospace domain or sports cars, luxury cars, with high product prices, and that's, you'll see that on the right-hand side of the slide here, i.e. in premium market segments, there is a justification for carbon fiber. There's some sort of, what we would call that a niche market, whereas in the high volume markets, low product price market segments, we will see in the future either aluminium or high strength steels or other materials that will be used there in the future for lightweighting as well. So yes, there is a place for carbon fiber in lightweighting, but it's going to be a small one, and we believe that will be staying rather small as compared to steel or aluminium or even magnesium markets. Does it answer your question?
Definitely. I think it gets us into two issues, but can I first ask you, what somebody in the chat panel has asked what lightweighting is. I assume we're just talking about making the same performance but with a less physical weight. Is that how you would describe lightweighting?
It's absolutely correct. We might actually get a better performance of the product, when we use less material. Save weight, that's the original idea of lightweighting, like for in aerospace, but we also look at saving materials altogether. Not using the material is, well, best material is not using any material at all. So from the design side, we get a huge saving for lightweighting, reducing the use of valuable natural resources.
That's great. So we seem to have, we're at a point here where lightweighting is clearly valuable. Carbon fiber can be part of that solution. There is a clear cost issue around carbon fiber and whether it can ever be a mass market product. There is also the issue that you raised of whether the energy taken to produce the carbon fiber is greater than the benefits of using that carbon fiber, which to some degree is a technical issue too, because if you could reduce the energy use for making the carbon fiber, you would get over that problem. Later on, perhaps we can come back to the issue of carbon lock-in in the material and the recyclability of carbon fiber. But I think we've got enough on our plate at the moment. So I'm going to pass now to Marcelo Liu. Some of you will remember he was on one of the previous webinars we did in the previous Build Back Better series. So welcome back, Marcelo, who is president of BASF Canada, obviously a giant chemicals conglomerate. So Marcelo, can you describe what involvement your company has in this space, in lightweight materials in general, in carbon fiber? And secondly, can you just comment on what you have heard from the previous panelists and tell us how things look from your perspective? Thank you.
Yeah, thanks, Diana. Thanks, Toby, and thanks, Ambassador. And great to be in the panel. BASF, actually 20% of our sales go into the automotive sector. We have a lot of business also in the aerospace sector. So lightweighting is part of our business for sure. We sell a lot of the thermoplastics that go into that, but not only that, additives that go into the metal that is also going to the vehicles. So we do have quite a bit of innovation going into that area in lightweighting. We also contributed to the BBC and even connected, the Alberta Innovates colleagues with OEMs that we already do business here in Canada, where I think a lot of the feedback on carbon fiber and potential using lightweighting came from. Yeah? Now, if you think about, and BASF has really flirted many times with using carbon fiber, carbon composites, similar to what Wolfgang just mentioned, the cost is just not there, and it has remained a niche application for a very, very long time. However, if I step back and I think a little bit about, how oil companies really diversify, and if you look at all oil majors, they do have a chemical segment, and I'm a bit biased because I'm in the chemical industry, but there is always a need to do additional value add to the oil. Yeah. And I think this is one of the key things that maybe some of the Canadian players have not done yet, is either partner very closely with the chemical companies or create a chemical branch on its own. And this is where all the interesting innovation starts coming with molecules like asphaltenes, which at the moment is a waste product, or not really waste. You need to burn it or do a process with it that is only increasing the energy intake in the process. Yeah. So if you think about the BASF way of how we are managing our production, we really are talking about a Verbund concept, which is synergy, putting a lot of production in one place and using the byproduct of one material into another one, and using the energy produced in chemical reactions to supply the energy of producing, the further downstream. So what you have there in bitumen in Alberta is a high concentration of material that is at low cost, because it's now considered a waste, or there is I would even argue a cost argument there, that you are able to use as a raw material to something like a carbon fiber, and volumes that have never thought before. If you think about the traditional carbon fiber route, which is the mostly used because it's the most pure, and you need that purity to get into aerospace applications, which is this polyacrylonitrile route. It has many different steps into the supply chain. And you can imagine that it's produced in one location and then further refined in another location and then shipped to another location. The interesting thing about the bitumen discussion here in Canada is that it's all concentrated in one location. So essentially you can skip a lot of the steps. If you're really able to convert asphaltenes into carbon fiber, you're able to skip a lot of steps, which would reduce the footprint that you have there. And of course, chemistry can add quite a bit into this. Yeah, you need a lot of chemistry in order to be able to purify the carbon, to be able to be used as carbon fiber, or the asphaltene to be able to be released from all the other side streams that you would have in the asphaltene. Last thing that I would say is, to get it really competitive, what you need to create is, of course, a process that is competitive for carbon fiber production, but I will never limit it to only that. You need to create adjacent and parallel applications like carbon nanotubes, and even as far as graphene, which you are able to do once you start cracking the nut on carbon fiber in its purest form. You start being able to produce or do other applications, which are much bigger value add, but again, niche, but it can only add as credit when you're talking about the competitiveness of everything. So chemistry has quite a bit to contribute. So that's why we are quite interested in the topic as well. Yeah, so happy to discuss more along the panel here.
Thank you, Marcelo. That touches on some of the issues that are arising in the chat panel about people asked about graphene, for example. But coming back to these markets, which Wolfgang and John talked about, and you also discussed, Marcelo. John, can I ask you what markets you considered? Because there are a few questions here about uses that people know of. So we're keen cyclists in Canada. There's high performance bikes. There's boats. There's aerospace. There's possibility of using carbon fiber in construction materials. Can you just describe the work you've done around those various markets and tell us where you think, which ones are always going to be niche? High performance bike perhaps will always be a very niche market, even though an important one here in Canada, whereas construction materials could really take off in a big way.
Sure, thank you. It's a real pleasure to have on the panel with people like Wolf and Marcelo. They know the market very, very well. If I can summarize the challenge, Wolf outlined the cost, number one, the GHG emission intensity in making the carbon fiber, and the production method. I think asphaltene does provide the potential to overcome these challenges, actually. So for a number of reasons. First of all, asphaltene can reduce the feedstock cost by 90% compared with polyacrylonitrile or PAN carbon fiber, which is a dominant carbon fiber on the market. Second, the carbon content in the asphaltene is 50% greater than in the PAN feedstock. Therefore, the theoretical yield will be much higher. Third, asphaltene contains over 50% aromatic rings that can be considered as a crude precursors to carbon fiber. The implication is that the energy required to convert the asphaltene to carbon fiber will be much lower as well. Lastly, asphaltene as a feedstock can significantly reduce the logistics and energy consumption in the carbon fiber manufacturing. I think Marcelo touched this a bit already. The GHG emission on life cycle basis from resource extraction, processing, transportation, and conversion would be much lower for the asphaltene carbon fiber. So for the reasons stated above, we believe actually asphaltene has a potential to reduce the carbon fiber supply cost by more than 50%, and the life cycle GHG emission by 75 to 90% relative to pan-based carbon fiber. So this is really lead to what kind of market now we can get into with those kind of reduction, both in terms of cost and in terms of the GHG intensity reduction. It certainly allow us to get into the mass market, for instance, auto, but also we can get into the mass market, which currently the carbon fiber is not even thinking of. For instance, in the infrastructure, in the buildings, reinforced concrete, so on and so forth. We had some, early on, we actually had some discussions with Lafarge. They indicated some significant potential on that space as well. So in another word, bitumen-derived carbon fiber will not compete really in the pan carbon fiber or currently commercial carbon fiber space. We're not going to that space. We're going to get into the space the current carbon fiber cannot go because those restrictions were talked about. And this is, from our point of view, how we can get into carbon fiber into the mass market.
Can I bring you back in on that, Wolfgang, and ask you whether what you've heard from John and even Marcelo makes sense? If we, is this just a technical challenge? Can we if we could overcome it, would you change your view of the possibilities for carbon fiber?
I mean, that is exactly what a few organizations here in Europe have been working on, reducing the cost of making the material and making parts from it, components from it as well. And what has happened so far is basically they failed to get to the targets that we actually need. I mean, if I'm saying a cycle time for a carbon fiber part is something like 1 or 2 minutes, this is the very, very lowest limit that is actually theoretically conceivable from the chemistry of the process. And it's very, very optimistic. And still you're far above that cost that you have in manufacturing for the common steel or whatever. So I don't see that happening. On the pan side, I don't know enough because we're not into making the stuff here in Baden-Württemberg in our province. But we haven't been seeing any price or cost reductions on the making of the material, interestingly enough. Although we have a huge overcapacity for carbon fiber production in the market, prices for carbon fiber have still been very high. And I believe this is because making carbon fiber or from the pan material is very costly still. But this is certainly something that Marcelo can better answer to. We haven't seen any substantial or sufficient price reductions in that case. There's one other thing I would like to mention. It's like, I mean, someone asked it in the chat as well. What about the construction industry? Yes, that is certainly a mass market. But again, there's the question, I mean, partly or mostly we do that because we want to make construction more environmentally compatible. But why would I use carbon fiber then over steel, for example? Because in making carbon fiber, I use a lot more CO2 than I can actually save in depositing it in the carbon fiber or in the concrete, of which I use less than over steel. So why would I use carbon fiber here? Especially as we do have other options, like for example, glass fibers, which we can be using, which are environmentally much better than any carbon fiber. So I'm very skeptical about that as well. Again, there might be uses for that in certain niche markets, which are fine. But certainly not in a mass market. And that is something that comes back to the question, or maybe that's going a bit more. I don't want to sort of steal your questions here, Diana, but it's about recycling and things and the environmental, the circularity of the entire thing. We have been talking about bio-based materials. There's a lot of Efforts around now here in Europe doing carbon fibers from bio-based materials, from cellulose or lignite, I think, from side products from paper making, trying to use bio-based fibers as such, not as a carbon fiber. And if we look at circularity and things like that, why are we not going going for that and putting all our efforts into that instead of still relying on fossil supply, which will be ending one day or the other anyway?
Thank you, Wolfgang. I'm going to turn the conversation. I'm going to come back to Carrie now, who obviously in her role at Suncor is, at the pointed end of this. Carrie, I want to ask you whether you, at this point in time, whether Suncor believes that carbon fiber production is compatible with a net zero Canada, to which we are committed by 2050. Is this a material, and are these processes that you believe could be part of that future? And relatedly, well, possibly not relatedly, but somewhat relatedly, I just wanted to ask you a little bit about the quality of carbon fiber produced from bitumen, whether it's the same as this pan-produced carbon fiber, whether it can really be used for the highest value markets. And my last question is, what happens to it at the end? How long is the carbon locked into it? So these are all related questions, and I'll pass over to you now. Thank you, Carrie.
Okay, thanks. 3 in 1. Let's start quickly with the qualities. So the short story here is I think it's not a one size fits all when it comes to carbon fiber properties. It's really a matrix of the performance qualities, or rather the mechanical properties. So tensile strength versus modulus or stiffness. So, and a lot of the context here is in the high performance category, and there's maturity in that market. But I think there could be an opportunity somewhere else in that matrix. So it's not a one size fits all. And we want to look across that entire value chain. So some important considerations are, of course, the low cost feedstock yield. So not just the carbon, accessible carbon once we remove impurities. I saw a question about that. So yes, impurities need to be removed, but then also the production yield as we go through. So and access to the aromatics that John talked about, and that structure of the molecules. So the difference with a pitch-based carbon fiber, which is what conceivably a bitumen precursor would be in the category of pitch versus pan, is that they actually can be treated differently and result in different mechanical properties. So I think it's more about taking a market first approach and understanding where are the gaps in the carbon fiber market that could be served by a bitumen or a pitch-based feedstock. So it's the feedstock, how it's processed, that gets you to that end product and the qualities. So that was the second question I think you asked. The first one was around carbon intensity. So we've had a great discussion about that. And yes, the production of carbon fibers does require energy input. There's a lot of heating involved, high temperature heating. So I think a full life cycle assessment, of course, of any process is going to be helpful in understanding the carbon intensity, the current state manufacturing process, and therefore how to inform how could it be improved. So, a lot of the process today, I think, came out of the pan polyacrylonitrile, which is based in textiles. So, I think there's opportunity for advanced manufacturing to look into how we produce carbon fibers and see if there's a way to change that up. Of course, there's 3D printing, there's, how can we decarbonize that pathway? So of course, energy sources for how we process and treat and manufacture carbon fibers are super important in achieving a reduced greenhouse gas intensity. And so I think there could be operational synergies. So coming back to Suncor being part of the conversation, there could be operational synergies for integrated companies such as Suncor when it comes to extracting that feedstock. So let's also clarify, there currently is not a commercial asphaltene feedstock available on the market today at scale. So we don't make carbon fibers commercially from bitumen today. There are other pitches that make up a small percent of the market, like maybe 10%, whereas pan's more like 90%. So there are some operational synergies with extracting, processing, separating, and treating asphaltenes as a precursor for carbon fibers. And if we can do that with reduced steps, as we spoke of earlier, then conceptually we would have lower cost structure and hopefully lower carbon intensity. That would be the goal. When you look at a acrylic or a pan plant, like when you just kind of take a look at what it looks like, which is the incumbent, it looks very similar to a refinery or upgrading facility. And so, you know, conceivably that would be compatible with Suncor operations in terms of our skills like operational discipline and the ability to deliver at scale. So as we look at doing technology development in this space, crossing that valley of death, as we call it in technology development, is really important. And we would need partners along the value chain that can help cross that valley of death and deliver things at scale, right? It's one thing to develop something in a lab, but how do we do it at scale? So that ability to scale up, super important. And I definitely think there's opportunity for advanced manufacturing to play a role here.
Thank you, Carrie.
Thank you.
There's a number of questions in the chat panel. Hopefully some of the more technical ones we can answer, give you some written answers. I want to turn back to Marcelo now. You have this, you've talked quite eloquently about the need for oil companies and chemical companies to work together to improve value and innovate. Do you see, you did mention that that's possibly happening less in Canada than in other places at this point. What's your reflection on Canada's ability to break into or create this market for pitch-based carbon fiber products, and what's stopping us doing that?
Well, I think the discussion today is relevant, especially in the whole carbon neutral story. I think the pressure is mounting that solutions like this are there. If you think in the past, I think there was an operational excellence driven by the oil companies in Canada to drive more oil production in a very competitive base, to really diversify into petrochemicals or into chemistries. I think that was not at focus. Now the Alberta government even has funding or even incentives in place to really diversify out of pure oil play. And I think one of the key things to look at is in the current operations, similar to what Carrie has alluded to here, and John as well, is looking at areas where there is no value add at the moment. Asphaltenes is let's say a dead material at the moment that you're just trying to get rid of it in the best way possible, and to really come up with a value add solution that actually contributes to the environment, meaning you actually put a value add and you get into higher end applications in a competitive way, I think can help a lot. There are some properties that I think we only scratched the surface here of what a carbon fiber or even some of the other materials that I mentioned, graphene and carbon nanotubes, are able to do. And really ties in with downstream industries that Canada wants to be a leader in. So if you're thinking about electrical vehicle production, which I think a couple announcements came out, if you're thinking about advanced textiles, which is something that is being looked at in British Columbia and also in Ontario and Quebec, carbon nanotubes. I remember in my time in Asia, we were trying to infuse that into fibers that allows conductivity to go through, so you can get wearables. So you can imagine you can get a lot of the sensors in place once you have conductivity in some of the fibers. So there's a lot of things that once you need to address costs, you need to address the footprint of the operation. But I don't think it's a fair thing to compare a footprint of a pan or to a bitumen. A bitumen, you are having a core operation, which is the oil production, and you're actually doing a benefit using the waste into a value add, instead of you creating asphaltenes out of nothing and then creating that carbon fiber, which wouldn't make any sense. So the economics here is different. The footprint here is very different. Also because pan has multiple steps, as I mentioned before, which actually this route, if successful, it avoids. Yeah. And one last thing that I need to mention, which goes back to Wolfgang's point, is, you know, even if we crack the nut on carbon fiber and being able to produce it at the right cost and the right quality, the approval processes to get carbon fiber spec'd in to an automotive part and aerospace part, it takes multiple years. So it's not something that, you know, we will crack the nut in 2024, 2025. We have massive amount of carbon fiber available into all these niche applications or very high-end applications. So I think it's absolutely relevant that we talk about construction, we talk about something else, which would address the lower grade, quote unquote, of carbon fibers that could be put into the market. Yeah. So last thing I would say is, you know, BASF has more than 200 types of thermoplastics that go into lightweighting of vehicles. You could have many different grades of carbon fiber that addresses different types of applications as well. But, you know, still a lot to be done, but it's possible. Yeah, back to Toby's aspirational statement in the beginning.
Thank you. I think another point that Toby made at the beginning was that this, even if we are successful in this space, we certainly will not be using the product from 3 million barrels of product a day. He was talking about 75,000, 2.5% of current production could create this market. So I know there's some concern about carbon fiber market riding on the back of a broader oil market that we will not look the same in several years' time. So, but a lot of this comes down to the technical challenges, including the challenges around energy use in production and recycling of the product, whether that's possible, how long the carbon lock-in is there for. So both the carbon, the cost curves and the carbon intensity of the processes. John, I know that Alberta Innovates has issued a grand challenge in this area, which sounds exactly what we have in front of us. Can you describe what you are looking for, who is participating, what you're hoping you will achieve through that, who is participating, and really what the time frames we're talking about are? We're obviously early on with a lot of the technical issues here. When do we actually see this being possible if we manage to get the technological things in place and cross the valley of death in terms of investment that Carrie referred to?
Yeah, sure. Before I answer that question, let me get back to Wolf's concern about the GHG mission again. You know, as I indicated, if we make carbon fiber from ash 14, we have a potential to reduce 75 to 90% of GHG emission. Right, so that is actually from life cycle analysis, and we are actually currently engaging another expert, LCA expert, doing a fulsome analysis right now. So it's a huge potential there, and talking about bio feedstock as well, Wolfgang, as you know, it's been pursued for many decades. The challenge is the yield is so low, the energy consumption is so high. In the end of the day, you use bio feedstock and it doesn't really help you. So and again, I want to emphasize there is a uniqueness of using ash 14 to make carbon fiber, but you know the challenge, the technical challenge is still very, very significant, right? So we've been making very good progress. We made some very good progress already, and that progress actually has been recognized by the carbon fiber manufacturers around the world. We talked to we actually brought in people from you know 3 largest carbon fiber manufacturers in the world into our labs, right? They are all excited, but we realize what we have is not enough. So we needed to broaden our reach and access more technical expertise around the world. So that's why we set up this $15 million carbon fiber grant challenge what is the purpose? The purpose is really to develop multiple pathways to convert ash 14 to carbon fiber, because relying on one or two technology providers is not sufficient. We need a whole innovation ecosystem to help develop this business. So currently we have a phase 1 of that grand challenge well underway. We are funding 20 projects around the world, actually mostly from Canada, but also from US and Australia, and all using the ash 14 feedstock we are providing. So the phase 2 of the grand challenge will be launched early next year, and we actually have funding in place already. So yeah, I guess that's what the grand challenge is about.
Thank you. The last question I want to get to, and I think I'll see who has something to say on this. I might start with Wolfgang, is the question of policy. We've had a couple of queries in as to what could change in the policy or regulation world that would change the structure of these markets. So would a carbon tax help or hinder? What other things might change the playing field in this space? So I'm going to perhaps go around and ask each of you for any views on that and any final small reflections, starting with Wolfgang, please.
Oh, I can't remember your question now. Now, well, policy impact. I've been mentioning the ecological impacts of carbon fiber and the debates over it, not for no reason, because that's something we have been seeing here in Europe in the last, I don't know, 5 or 6 years, that politicians got more and more aware of the environmental impacts of carbon fiber, the detrimental impacts of carbon fiber. So, and it doesn't take long before you have some Greens or whatever at your heels, sort of debating the sense that you're making out of using carbon fiber. As I said, there is certain applications where it does make sense ecologically, but there are many areas where it does not make that much sense. The question, and that came up in the chat here as well, can we make it green by using renewable energy to make carbon fiber? Yes, of course we can do that. Apart from when I dig or use bitumen, which I dig out of the tundra basically in Canada, which is probably not a very good thing either. For the environment, I can make it greener, but the thing is, most scenarios where we are looking at changing our society's energy supply to a renewable source is assuming that we have to save energy instead of using more and more and more of it, because even on that side, resources are pretty much restricted and limited. Principally, yes, the answer is could be, but certainly this is not without problems either. What I do see is as an impact on the carbon fiber market is the CO2 pricing, as we have just introduced that now in Europe, or in Germany at least, where we are putting a price tag to CO2 emissions. Because that essentially that has been driving the entire lightweighting efforts in the last, 10 years or so. The CO2 emission scenarios that the EU imposed on the automotive industry drove the lightweighting efforts in the automotive industry, and carbon pricing at the moment, the CO2 pricing at the moment, is driving the same lightweighting efforts now in other areas and in other industries, like in the capital equipment, like machinery, manufacturing equipment, and even in the very conservative construction industry. And everybody now starts thinking about getting into a circular economy, CO2 saving economy. So that is certainly a very, very valid driver for lightweighting.
Thank you. I'm going to give everyone 30 seconds. Everyone else, just final reflections in this space. Carrie, next, please.
Thank you very much. Yeah, I'll just comment with to be competitive in a new product category such as this, we're going to need to, and we want to have it homegrown, we need to develop that expertise and skill set. So product development and like almost having a test facility, a center of excellence to build those capabilities in Alberta and in Canada, and leveraging our manufacturing hubs as well. I think that's really critical, because doing something in the lab and then doing something commercial is you know, a very long development path. So having the ability to test and integrate into the markets is important.
Thank you so much.
Thank you. Thank you for having me.
That was wonderful. Thank you, Carrie. Marcelo?
No, I need to agree with Carrie here. Back to my partnership and cross-industry support, yeah, the aerospace, the automotive sector, working with these companies to really do the proper R&D to make this competitive, and also to address Wolfgang's point on, you know, the environmental aspect. I think as we need to continue for whatever time producing oil, we will have these side streams, and might as well do something with it instead of just leaving it there, right? So that would be my take.
Thank you so much. John?
Yes, you know, certainly we've been talking to lots of people. Looks like we needed to spend a bit more time with Wolfgang. You know, we still very strongly believe we're on the right direction. Lots of potential here. We needed to work with lots of partners.
Thank you, John, and thanks for the work that Alberta Innovates is doing. I'm going to hand over now. I want to thank everyone who's joined, and for the active chat and Q&A windows here. We will capture and think about those. I also I want to point up the next event, which is not on in exactly 2 weeks' time. It's on November the 12th, when we'll be looking at opportunities around hydrogen, which many of you know will potentially is a very important part of our net zero economies, and one in which Europe and Germany specifically have made some strong commitments, and Canada is working on its hydrogen strategy. So that should be a great event. But now I'm going to hand back to Toby and then Ambassador Sparwasser for any final goodbye and words from them. Thank you. Toby?
Yeah, thanks. I think that was a, of all the roundtables we've held, I haven't seen as intense of a reaction from the audience as this one. So we're on a live wire. This is where the action is, and where there's a need to apply and build on focus that we've already put. And this is where there's a potential replacement. This is where there's a potential home run for our country, in a place that has had not such great news and some bad news in the last year. So this is something for focusing in. And Wolfgang laid out some of our challenges. And we'll be posting a good segment of the Q&A and comments online with answers to answer a lot of the material that didn't come out in the conversation. But thanks everyone for participating. This was a really substantive and meaningful discussion.
Absolutely, it was a great panel. I do thank all the panelists. Finally, round back to Ambassador Sparwasser. I hope you enjoyed this and you learned.
Thank you. We promised each other we would have a steep learning curve. I certainly had one. I learned an awful lot. I really understood that on the one hand, we have a resource that is coming from waste and we can do something with, but on the other hand, we have to get the pricing right, and we have to get the environmental footprint of that production right. But I still see there was lots of potential, but it also was a great webinar. It was great debate. So thank you, Diana, to you. Thank you to Corporate Knights, and thank you to all the panelists.
Thank you.
Thank you.
See you soon. See you in a couple of weeks' time, just over. Bye-bye.
Bye.